Okay, so hopefully my voice is clear. So in this video, I'm going to cover a very interesting topic, which name is mesh analysis. So before knowing how to apply mesh analysis on circuit, we have to know that what is the need of mesh analysis. So in this case, we have a complex circuit. So here we cannot apply any type of series parallel equation or current divider law or any type of voltage divider law. So now the question is, in if we have a that type of complex circuit, what should we do? How can we solve it? So if we have other type of complex circuit, we can easily solve it by using mesh analysis. So now the question is, what is mesh? Okay. So a loop which does not contain any other loops within it, it's called a mesh. So now the question is, what is loop? So a loop means a closed path. If we start our journey from a particular point A, then again back to the point after some period of time, it's called a closed path. So in this case, we have a loop. In this case, we have two different mesh. One, suppose one is mesh 1 and one is mesh 2. Okay, then go to the next part. What is mesh current and what is branch current? Okay, so in this case, we have, suppose we have three elements. One is R1, one is R2, one is R2, and the other one is R3. So if we look in the R3 element, we can say that, suppose the one is mesh 1, here is the name of that mesh is, suppose the name of that mesh is mesh 1 and the name of that mesh is mesh 2. Okay, so if you see that the R3 element is both the property of mesh 1 and mesh 2. So now the question is how we can get the current of the R3, because we can easily get the current of R1 and easily get the current of R2, because the R1 current is same of the I1 and the R2 current is same of the I2. But the problem is with the R3 element, how we can get the R3 element. If we write it, if as we are writing, if suppose you are writing the equation of mesh 1, in this case the main current will be I1, and if you write the equation of mesh 2, in this case the main current will be I2. So now the question is how we can get the R3 current. So as we writing the equation of mesh 1, in this case the main current will be I2, so just simply write the R3 and then just write it the main current and then subtract the rest of the current from the main current. In this case the rest current is I2, just subtract it from the main current. If you write it the mesh 2, if you write it the mesh 2 equation, then the main current will be I2, so just write it the R3 the main current, then write it the main current and then subtract the rest part of the current. Okay, in this case the rest part is I1. Okay, by doing that we can easily get the desired current of R3. Okay, so now let's jump into the next part. What is the process of mesh analysis? So first, the process of mesh analysis is assign current in the clockwise direction. Assign current in a clockwise direction. Okay, then the point is apply KVL. And the last part is solving the resulting equation. Okay, so the now okay, the first part is assign current in a clockwise direction. Suppose we have here a circuit. In this case, we have two different mesh. Suppose one is mesh 1 and another one is mesh 2. Okay. The mesh 1 current is I1. Suppose the mesh 2 current is I2, and the mesh 1 current direction is clockwise, the mesh 2 current direction is clockwise. Then apply KVL. If we apply KVL on the mesh 1, we clearly see that the current is passing. If we consider our journey from the lower left corner, we can easily say that the current is passing. The current is going to the voltage source from a negative side there. So here is minus sign, then V1, then the R1 I1, because the R1 and I1 both same in this case. We can easily write it the R1 R1 and R3 is the complex element. In this case, as we writing down the mesh 1 equation, the main current will be I1. That's why here I1, and the rest current is I2, and we are getting and we are subtracting it from the main current. And if we're writing down the mesh 2 equation, we can here is the main current is I2 and the R2 and I2 is seen. That's why here we are writing it's a R2 and I2, and the current is passing from the resistor positive. So we know that if a current is entering from a resistor is called the positive side. If we current passing from and if the current is existing from a resistor, it's called the negative side. Okay, in this case the current is entering from a positive, that's why here it's the positive side. Okay, then R2 and I2, then the current is passing from the voltage to positive side, that's why here is positive sign, then V2, then R3, and the as we writing down the equation of mesh 2, the main current will be I2. That's why here I2 is in the first position, then subtract the rest current I1. And by doing that, we are easily getting the equation. And after getting the equation, we can easily solve it from the problem. So let's now quickly solve our problem from by using mesh analysis. In this case, we have two mesh. One is mesh 1, suppose one is mesh 2. So if we apply mesh analysis on mesh 1, we can easily say that the current is passing from the negative side on the voltage, so we can write it minus 42. Then the current is entering from the positive side of a resistor. As a result, we can easily write it here positive sign, then 6 ohm. Then the 6 ohm current and the I1 is same, that's why 6 ohm into I1. Then the current is entering from a positive side of a resistor. As a result, we are giving here plus the as we are writing the mesh 1 equation, the main current will be I1. So we are writing here 3 ohm, the main current I1, then subtract the rest current I2 from it. In the right side 0. We can easily say that here the equation and the we are and the equation we write both are same. Minus 42 plus 6 into I1 plus 6 into I1 plus 3 I1 minus I2, and the right side we are having 0. Okay, if we write it in the equation of mesh 2, we can easily get the here the main current will be I2. So I2, the rest part will be minus I2 minus I1. I2 minus I1. The current is entering from a positive side of a 4 ohm. That's why positive for I2. And the current is entering from the negative side of a voltage. So that's why here minus 2. After getting the equation by using calculator, we can easily solve it, and by that we can easily get our desired result. I1 is 6 ohm and I2 is 4 ohm. That's all.